Welcome everyone. So for those who kind of missed my opening, yeah, thank you for joining us for today. Today we're going to be taking a look at Verity 2.0, the long-awaited Verity for Revit. So I think if no one's familiar with Verity, then Verity is the ClearEdge 3D premier tool for construction verification as well as model validation. So to kick things off, let me go ahead and let's pop over to the next slide. Just kind of a couple little housekeeping items for today. Number one, participants are muted during the presentation, so we'll just keep that one just to keep everything running smooth. That way we don't have everyone talking. Got quite a full house, it looks like. Number two, questions. GoToWebinar has a handy dandy little chat functionality. So at any point, if there's any questions or anything you'd like clarification on, feel free to use the chat function over in the little GoToWebinar thing. We'll be keeping an eye on that. We got Justin Dahmer as well as Sam Shield from our team answering questions throughout the webinar. Number three, we'll do a couple little QA breaks. We'll actually take some questions. The big one is we'll actually have some polls. So we've got a couple loading bars today where me and Jordan will be talking, as well as Michael Clark, who will be joining us shortly, as well as we'll launch some polls. That way we can get kind of some questions kind of coming from the audience. Number four, for anyone coming in late, the webinar will be recorded for today. So we will be sending out the recording once the webinar is over. And yeah, that's kind of number five right there is you'll get a follow-up email with all the information contained for today. All right, so who are we, your wonderful team here presenting on our webcams? So I'll go ahead and kick things off. I'm Trevor with ClearEdge 3D. I handle industry strategy and relationships. A lot of you guys, I think, know me more for doing demos, answering technical supports. And if anyone's ever caught me at a conference after a few margaritas, apparently I'm quite known for my laugh in the industry. So good to have everyone here today. And I guess, Jordan, I'll kick it over to you next.
Hey guys, my name is Jordan Bullock. I'm actually with our Topcon Solutions team, which is a sister company of ClearEdge 3D. We all fall under the overall Topcon umbrella. I'm a technical specialist and implementation consultant. I'm also an Autodesk and Bluebeam certified instructor. I take care of all technical support, and with the launch of Verity 2.0 here today, we're going to talk about the Revit integration there and get into that. So I'll be answering questions here in chat as well. So anything you guys need, feel free to pop those over in the questions mark. And then if you guys have any general comments today, there's a chat functionality here as well that you guys can throw questions and comments in. Michael.
Sorry for being late. I apologize. My name is Michael Clark. I'm the Director of Field Engineering for Rogers O'Brien. We are a premier GC in the state of Texas, so I handle all of our layout and on-site quality control for as-builting, things like that, across the entire state.
Perfect. And let's take a quick little look about a little bit of background. So Jordan, we got Topcon Solutions Store with us. You mind telling us a little bit about the Solutions Store?
Sure. Topcon Solutions is the retail division of Topcon Positioning Systems. And as I mentioned, we're also a sister company of our ClearEdge 3D team here today. So we are an industry leading partner in training and technical support for Autodesk and Bluebeam solutions. We also are a distribution avenue for all our Topcon positioning equipment. So it's kind of hard to explain what we do all in kind of one package, but we have our little wheel guide here. We do everything from hardware distribution to software sales. We offer training and support on everything we do. Anything hardware related, we're actually, some cool facts about Topcon is we're in pretty much every single John Deere tractor with our machine control technology, but we offer repairs, services on site or in any of our training centers located across the United States here. We're kind of spread all throughout the US, but we do serve all the US. So if you don't see a specific store in one of the states that you guys currently are in, we do still service your territories. So feel free to reach out to us. We're also a multiple recipient of multiple rewards for our outstanding business outcomes and customer support we provide. And we've been an Autodesk and Bluebeam partner for well over 20 years now.
And we'll just tack on real quick. Even though I'm doing the demo, I make no claims of being a Revit expert, and Jordan has been fantastic kind of teaching me some little things about Revit. So I will also vouch for him in the Topcon Solutions Store for that one. So next
sir.
up, yeah, Rogers O'Brien. Michael, tell us a little bit about Rogers O'Brien down in Texas.
Yeah, so we operate solely in the state of Texas. We have no designs of leaving Texas. There's more than enough work here than we can handle. We are a third generation family owned company. It started with Pat O'Brien and his business partner, and then Pat O'Brien, bought him out, and it's been handed down from father to son throughout the years. Justin McAfee is our current CEO. We operate in now 5 different regions within Texas. So Dallas, Austin, San Antonio, Waco, and Houston. Doing a little over $800 million in revenue across 14 different sectors. I mean, I started with them a little over 12 years ago, and back then we were doing maybe 150, 200 million a year. So it has been a huge explosion of work and just company size. I mean, I remember when I got hired on, we had maybe 100 people in the entire company. Now we're a little over 500. So just trying to keep up with that scale from a layout perspective and quality controls perspective has been quite the feat, I'll say right now.
No, it's what's that famous quote? Everything's bigger in Texas. So let's go ahead and actually jump in a little bit into the meat of like today's presentation. So the state of construction. So kind of one of the big, or kind of some of the key metrics to talk about is number one, the direct cost of avoidable construction errors amounts to about 5% of total project value. It's always been something, especially going to conferences like Autodesk University. I feel like everyone here has their construction horror stories where, someone will be staring at a drawing, then you look up and you're like, that's not being built right. And again, all those things have a cost, and so that's kind of, I think, a big thing in this market is just how much mistakes and rework actually really affect us, and kind of what tools we should be leveraging to really kind of, I guess you could say, like, eliminate that, because that should be stuff, even though we don't live in a perfect world, I feel like we definitely have the tools where we can kind of get close or definitely alleviate a lot of the pain that we're experiencing. So, and I think that big one there at the bottom is fewer than 1 of 3 contractors finish projects on time and within budget. And again, I feel like that's something that everyone, having a couple beers at a conference, everyone will tell you their project horror stories where something went vastly out. So I feel like that's definitely a common thing. So, and then for that, this is the solution that Clearidge 3D, seeing that there is an issue in this market, this is what we propose, and that is Verity. So what is Verity? Verity is a companion tool for either Navisworks or the brand new Autodesk Revit. And what Verity allows you to do is it allows you to compare any kind of geometry to the point cloud. And then Verity will actually go through and say, is this item found within the point cloud? Is it built? And if it is built, is it within tolerance? So that way users can quickly validate the installation accuracy of any kind of geometry using the point cloud, and very quickly and very efficiently. And again, we'll be taking a look at that here quickly with a demo, as well as a nice case study, Michael Clark, our power user. So, all right, so the big thing with Verity 2.0 is Revit. So previously, Verity had always been integrated into Navisworks, and that allows us to actually go through Navisworks was Autodesk Premier, or is Autodesk Premier tool for clash detection and coordination. And Verity allowed us to not just compare model to model, but model to point cloud. So the big kind of, I guess, thing that could happen, and what Verity was known for, was Verity would actually take the geometry and move it and fit it to the as-built inside of Navisworks. And so everyone saw that and they were like, hey, can you guys do this in Revit? Like, that would be amazing. Also, Revit had the full reporting capability. Again, Revit being the premier tool for producing, construction drawings. So it made a lot of sense to take that capability out of Navisworks and then actually plug it in so we could do the analysis directly on the BIM, bringing over those key functionalities that everyone loved from Verity for Navisworks, and again, porting them over for Verity for Revit, including the ability to actually create a copy of the as-built directly inside of Revit, as well as color coding the Revit geometry to quickly see the installation statuses and the tolerances of everything right there on the spot on your BIM. So as I talked about, the big one is kind of copying that as-built geometry. So that's a really cool functionality. I think that's one that a lot of people get excited of. And as the product grows and matures, that's only one that's going to get better and better. Who knows, maybe the holy grail, click a button and it'll transform your whole BIM to an as-built. So much for as-built modeling. We'll see, future development, not making any promises. The other key one is Verity gives you a very powerful visualization tool showing how the differences between as designed and as built, as I think everyone can see there on the right, kind of the two images. And then, yeah, the last big one is it basically creates that, I think the proper terminology, Jordan, correct me if I'm wrong, is an in-place object, where it'll actually take the existing family, copy it, create that in-place object, so that way we can see inside of Revit what actually got truly installed. Yeah, and so the cool one is the reporting side of things. Here's an example of a Verity report. So Verity being plugged into Revit allows us to take all that great information that Verity is finding, pushing it back to the BIM. And then from that point, we can piggyback off of Revit's own natural or Revit's own powerful capabilities producing sheets and drawings to really make these fantastic reports, highlighting both using the heat maps that Verity produces, custom annotations. Again, it really, I think, is a very powerful QA/QC platform. Now the fact that we can basically take all that information and then present it using kind of the powerful tools that were in Revit originally. And that might be something, kind of a general question for the audience is like, as Verity develops, you know, what would everyone want to see in like a construction validation report? Would it be something more in a simple? Would you want more kind of fine-tuned kind of like information? You know, that would be kind of a big question I have for everyone here is like, what would you guys want to see in say like an automated report that Verity would produce? So why use Verity? So a couple of the bullet points here: identifying construction and modeling errors before they can create downstream impact. Again, I think we've all got those hidden stories of where maybe something was like they didn't know until someone tried to run like a duct or an MEP pipe, and then it was like, uh-oh, you know, too late at that point. Another key one is coordination. Again, similar vein is being able to quickly find these issues and then say, okay, we've identified this issue, how can we work around this? Or do we have to rip it out and redo it? Again, that's all kind of key information that Verity will identify using the point cloud as well as the BIM kind of bringing that together. And then by finding these pieces of information, Verity can help you reduce redesign, re-engineering, and rework costs. That's all things that we can very quickly basically find. Instead of having the spot check, let's just say like, you know, 10% of the model and hope we catch something, we can use Verity to spot check a whole, or to check a whole floor using the point cloud to find all those little as-built conditions or things that we might be missing otherwise. And then why does this matter? The last big point, protect your budget, schedule, and profit. Again, we can find things, we can correct them, and hopefully that's all money in the pocket. So that's kind of the big one right there. All right. So here's the fun part. So now let's actually go ahead and do the demo. So thank you, Michael. All right, so here's our little sample project right here. So as I mentioned before, I make no claims of being a Revit expert. So you know, this is kind of me doing a little bit. But so what we're going to go ahead and do is we got our point cloud loaded in. We've got our geometry. Let's go ahead and actually analyze this in Verity. So the first step, what I'll go ahead and do is I'll choose what things I want to analyze. So in this case, I'm just going to grab my structural steel beams on my top floor, and I'm going to go ahead and import all of this from Revit into the Verity application. So a very key distinction I want to make is that Verity does not do modeling. It's not a modeling tool. It's a comparison tool. The reason I really want to stress that is because any kind of geometry is fair game to compare against the point cloud. So in this case, we have some structural steel, but even if we had like say pumps, equipment, MEP, it doesn't matter. It just has to be a family object inside of Revit, and then we can compare that to the point cloud to actually get our results. So, and then here shortly, we actually have Verity. So Verity is our little companion tool. So here's our window right here. Now that I have our items loaded in, this is where I can go ahead and do my analysis. So, all right. I'm gonna go ahead and I'll grab some scans. So I'll go like here, turn on my links, grab like one, and I'll grab like this one right here. And I'll go ahead and import this over. So this will bring in our scan data. Right now, Verity primarily works with the recap project, works best with using tripod-based scan data. We'll talk about that a little bit later on. And currently right now in beta, we do have the ability to work with SLAM solutions like the Navis, for example. So we have our items loaded in, we have done our analysis, or we have our items loaded in, our point cloud. This is where I can go ahead and perform my analysis. So I'll go ahead and click my Analyze toolbar right there. I'll just go about an inch, and then we'll go ahead and let this run. So we've got about, I think we got about 2 minutes and 30 seconds at this point. So this is where I think we'll go ahead and take a quick break to maybe do a poll. So we'll go ahead and launch that now in the chat. And I guess as we got that going, I guess, so Michael, you've been kind of one of the big users of Verity. And how has that been? I know you think you've worked similar to what I've done, kind of working on structural steel.
Yeah, so we've been doing a lot as far as in-field QA/QC checks, mainly for things like high-rise buildings, data centers, things like that. And we've kind of bought all into the clear edge workflow. So that's actually been helpful for us. I know y'all are software, hardware agnostic when it comes to Verity. However, when we do use the entire clear edge workflow from the GTL to collage site to tools for Revit, all the way into Verity, we're able to like really streamline that process, and we're getting a lot of value out of this with something that we call speed of knowledge. It's kind of a term we coined here at RO. It's basically how fast can we get the data back into the hands of the people who can get it corrected, get the issue solved. And this workflow has really drastically changed how we approach QA/QC on our projects, especially when it comes to things like structural steel, tilt wall panel, cast in place concrete is always a big one. So I'm going to go over that one of our projects here during my little demo here in a little bit, but it's really been a phenomenal tool to quickly identify what are issues, what could potentially be an issue. I do love the fact that we can push properties back to Revit now. I mean, that makes it a huge help for us, and the colorization tools that y'all did. I mean, that we work with a lot of superintendents and project teams who are very visual learners, and being able to send them even something simple as a plan view of saying, hey, everything in green is good, everything in yellow we need to have a look at. That really helps them figure out, okay, well, what's going wrong, what's not. And I'll be honest with you, out of all the tools and everything that Verity can do, your point cloud heat map has been probably one of the biggest helps in my opinion. Only because most things in Revit, it's all plumb, squared, whatever. That point cloud heat map can tell me deviations in concrete, and that has been a huge help for trying to get the point across of, well, yes, we have a wall, it's saying it's out, but it's good at the bottom, it's good at the top. What happened? Oh, it blew out in the middle, and that's how you can really show that with the point cloud heat map.
No, I think that it's been interesting, just that whole thing of like, I like to say, like, we live in a 3D world, but I feel like a lot of the reports and a lot of the stuff we do is very 2D kind of stuff like that. And I think it's been interesting seeing as we kind of use the BIM and color codes more, it almost kind of like, it makes a lot more sense instead of just trying to stare at something and be like, what is that? just being able to slap down a very color-coded geometry and say, hey, this is what we have right now. I feel like that's probably one of the most powerful deliverables that we have. And I think your experience confirms that, you know. I believe, so Verity is done. The good news is it look like we have a lot of passing. So let me go ahead and, I think everyone can see my screen once again. And look at that, we got some greens. So that's always a great sign. So this is one of the first things that Verity creates when it's done. This is the summary report. So this is basically a pie chart overview, kind of letting you know what we found. So we got some passing, looks like we have some out of tolerance, a couple not founds and some occluded. So again, good mix of elements right here. Coming back to Verity, let me go ahead and, this is always better with dual monitors, but make do. If we actually click on one of our items, I have a couple things. So let me go ahead and turn off and let's take a look. So the purple is the design condition, or what was actually in the 3D model to begin with. That cyan or kind of teal, that represents the copy of the geometry that Verity has created and refit back to the point cloud to actually show us the true as-built location of what should be there. If I scroll down on the side of the Verity window, you'll see all my metrics and properties right here. I can see like the installation status at 1 inch, it's currently out of tolerance. And then furthermore to the right, and this is kind of the real, I guess you could say, meat, is the translations. So the total translation in this case is almost 3 inches out of tolerance at the worst spot between as built and as design. And then it breaks that number down into all the different component vectors down to the right. So a couple of the key things kind of showing some of the core, I guess you could say, Verity functionality is, in addition, we can basically scroll through, kind of checking our elements like this. But with some of the new enhancements working on Verity for Revit, let me go ahead and let's pop this real quick. So
can I jump in on your screen on the right just for a second, Trevor?
Oh yeah, go for it, Jordan.
This is really cool. I just want to make sure we emphasize it and kind of show it. Do you mind pulling up the element again there?
Yep. Let's see. Oh.
I think you just did a select all. So There we go. Perfect.
Yeah, there we go.
So this is a really cool process. So what Verity is actually doing, just to kind of reiterate a little bit of the process and just catch anyone up that may have missed some of the beginning portions. So Verity is a tool that is analyzing scan data and it's comparing it to your Revit model. So this can be done in multiple instances in multiple places. You go out and do an as-built model at the end of a project, you can compare it to what you designed and how well the installation and the design is actually comparing. In addition, you can do it pre-designed. So you go out and you start creating your building conditions, you go out and scan your building, you can come in and as you're building your as-built Revit model, you can check for accuracy in the Revit model that you're building compared to the existing condition scan data at the very beginning. So the cyan color you're seeing on the right is Verity actually analyzing the 3D modeled element. The cyan's the blue one there.
Oh, yeah. Got my colors messed up, yeah.
So that is Verity actually analyzing the scan data for the existing element that's actually there. So there's nothing actually modeled there. That's the scan data, and that's Verity's expertise being able to compare and recognize the element that's actually there. The magenta color you're seeing there, that is what has been built inside of Revit. So that is your modeled element inside of Revit. So anyone that's been using Verity for a while, you've had this functionality and these tools and analysis capabilities from Navisworks element. Now what we're doing is we're bringing those directly inside of Revit. And what Trevor's going to show you now is what you can do with this data and information. So the cyan's what's been built in the scanned 3D model, and then the magenta colors, the element inside of Revit right now from that exported analysis that we've conducted.
Yeah, no, thank you, Jordan. And then a couple of the other cool new functionalities I really want to highlight is check this out over on the Revit side of things. Look at those color codes. So that's what Michael Clark was saying is we can very quickly, I did a select all using our push properties, the host button right there. I can click and there you can see right there the status. So if I click on one of these beams, I can actually then see the corresponding element inside of Verity just at a click of a button like that. In addition to the color codes, if we scroll down into our element properties, check that out. We have all our information right here. So I can see the total translation. And I believe, Jordan, correct me if I'm wrong, all that information then comes into where I can build schedules and use that in additional platforms, just to throw it out there, maybe like Revisto in those dashboards. And again, I think that's a Go ahead, Jordan.
No, you're okay. So everything that Verity is analyzing, all of that data that you typically see within Verity is coming in and being input in parametric parameters inside of Revit. So each of your element has a unique parametric piece of data that Verity is bringing in from its analysis in relative to where the scan data is in comparison to your actual element. So all of this can be scheduled out. You can run reports on this. You can create tolerance schedules. But what's really cool here is the mapping functionality that Trevor's talking about, and Michael said he has a lot of value in. This color code that you see on the screen is actually in reference to how far your scan data is from the actual elements that's designed. So this is almost like an in real time comparison of whether you're good, if you're off a couple of inches, if you're off a lot from the scan data. And this is in real time a recoloration of your elements based on how accurate they are compared to the scan.
No, and again, just kind of maybe highlighting just kind of synergy. We can also do things like if we're trying to find an element, we can throw on the section box command. You'll notice Verity actually creates a special little Verity view inside of Revit, like so. So that way we can quickly isolate the element, again, finding it, especially in more crowded projects. So we really want to highlight the fact that both Verity as well as Revit are both working kind of really well in conjunction with each other. Again, a little bit crowded on my screen, but dual monitors, fantastic workflow. So yeah, so let's go ahead. Again, we got our color codes over here. Another really big piece of functionality, and I'll kind of, oops, we'll go on that one right there. Turn my section box off real quick. There we go. Right there. Hopefully everyone can see this, but it's the new creation of the as-built geometry. So if I click that button, you'll notice it creates this right here, in-place family. And Jordan, you mind actually explaining a little bit about kind of this piece right here?
Sure. So inside of Revit, you have the ability to create in-place objects based on non-traditional shapes inside of your model. So what you're seeing in yellow versus what is actually selected by Trevor, it's essentially creating an in-place just modeled element based on the scan data. It's similar to on the right-hand side inside of Verity, what Verity is analyzing in that cyan color there. So your yellow element on the left, that is your actual family that someone's input and modeled inside of Revit versus the in-place family, which is just a component that, it can be in there permanently, but it can also just be a temporary kind of location element where then you can go through and place an actual family in there.
No, and that's not perfect. Thank you for that, Jordan. That's something I've had to learn recently. I got a little bit harped on and kind of the difference between the two. But that might actually be another kind of key question, I guess, for the audience is like, would you guys rather have a copy or would you actually want it moving the true object that you have inside of Revit? That might be, something to discuss and, love to hear your feedback. I know there's pros and cons to both, but again, definitely interested to hear any answers in the chat. So, but we've got our elements right here. We've got color codes, and this is where you can really take advantage of, for example, Revit, of producing maybe a quick little sheet from this. So let me go ahead, maybe do a quick little, but we want sheets right there. So I'll go ahead and create a new one real fast. Yeah, let's just do something like that. And again, just doing this as a quick little sample. And we can go ahead and take our view. So I think top beams is the one we want. Okay, oops. Jordan, I might need some more Revit training from you.
Okay.
Yeah,
what are you trying to accomplish?
I was just trying to drag over the view to my sheet. Oh, there we go.
Okay, there we go. Yep.
And then,
yep, just drag and drop it there.
Yeah, something like that. And there you can see we got our color-coded geometry on a sheet that we could then play around with and again, build it out and kind of create a report. So right now, it is a little bit more on the manual process, but again, that's kind of coming back to one of the original questions I had is I'd be really curious to see everyone's opinion on what would you want on, let's say, like a fully, again, maybe automated report coming out of Verity for Revit. What things would be important to display. So. But yeah, that's kind of right there. I think a good little example of, there's our little report, got it on a sheet, and then we could get this out. And coming back to Michael's point about that currency of information, that was about 88 items. We got the structural steel floor analyzed, a few scans up there. all within, besides me fumbling around with Revit, got it all out in probably a couple minutes or so. And again, ensuring that currency of information, getting fast results back to the field so that way people can make decisions based on that information. So, but yeah, no, that's our quick little Verity for Revit demo. And with that, let me go switch things around. We'll go back to our PowerPoint real quick.
Yep, so I think we're gonna jump over to Michael next. And Michael has been using Verity for quite a while now and been using it on real life cases in demonstrations. So if we wanna go ahead and jump into Michael, I think he has a slide deck he's gonna bring up, and we're gonna take a look at a real life example of how Verity is used in the field and how that saves some time in construction.
Perfect. Yep, Michael, let me go ahead and I will, I think I'm stop my screen share, and there you go.
Come on. Sorry about that. Can y'all see my screen, or do I still need to?
Yep, we can see it and we can hear you.
All right, cool. So let's get going here. Again, we've been using Verity for almost a little over a year now. And with this beta test we were asked to help out with, we decided to put Verity for Revit on a high-rise project in Austin. Here are kind of some of the details of this project. The first one being it is a 32-story high-rise in downtown Austin, all cast-in-place concrete with precast panels for the entire exterior. So a lot of our concrete had to be we had very low tolerance on our concrete as far as where it was placed and the quality. So attention to detail and being able to do quick QC tests on all of our columns, walls, and slab edge was essential. This is kind of a quick step-by-step process of how we actually go about getting this information from the field back to the office, and then again, right back out to the field again. So like I've told before, we kind of bought all into the clear edge workflow. So when we get a floor to go scan, usually after everything's been stripped, cleaned, we're ready to go set control. So using the GTL 1200, we will take our, go up to the floor that we need to scan, set all of our controls, elevations, everything like that that we need to scan the project. And then we would do, we perform 10 scans for each floor. This process would take, I don't know, roughly around 2.5 hours. So it's fairly fast considering how much information we're actually collecting. And this is kind of what the information we would get. We would have 4 scans tied to control and the other 6 registered cloud to cloud. What was interesting about this whole process is the use of collage site. I know this is a Verity webinar, but I would be remiss if I didn't mention collage site. This allows us to register our entire point cloud to control in the field in real time, meaning that by the time we are done taking all of our scans, I have a registered point cloud ready to send to my office staff. Just a quick export. It's all structured, registered control. I know it's right. I know I have all the information, and that has really streamlined our process. After that, as far as getting everything put into Revit, I will stress this time and time and time again. I know Trevor's probably tired of hearing it. Control. Use control and coordinate systems. Put everything on the same coordinate system and tie all your scans to control. By doing that, you can eliminate errors in alignment and create consistency in your workflows. It's something we're doing here at Rogers O'Brien. We're now putting all of our Revit models on a shared coordinate system that aligns with our field teams, meaning that any information that I collect from the field, we can easily and seamlessly put it into Revit for comparisons. No more visual alignments. We are going away from the visual alignment tool for any kind of point clouds or the Revit model. They're not accurate, they're not repeatable, and they're not consistent. It's just a quality standpoint on that end. Not to mention that by doing this, I mean, I can get an entire point cloud for 15 floors in a Revit model within a minute and a half. It's just a simple link, manage links, and I'm not a Revit person. I mean, Trevor blows me away at Revit. So if that tells you any idea where I'm at. Yeah, I went to Google or YouTube University to learn my Revit skills. So I can easily put in several scans into Revit within a few minutes. I mean, it's just that whole time comparison. I don't have to worry about nudging or trying to align with a singular column and worrying if it's off on another end. It goes in, I know it's right. And then running the Verity analysis. After we isolate the floor that we want to work in, I can go in there and select every column, wall. I don't know if Trevor knows this, but I actually also do slabs every now and then as well, and it works. I know it's not really designed for that. However, for slab edge, it works very well. But the main one is columns and walls. And again, it takes a couple minutes to load into Verity with the point cloud that I need. And I have now verified every structural element on that floor. Input the properties back into Revit, and I'm ready to do a coordination with the project team on what's wrong, what's right. I mean, look, I can send them that picture right there and say, hey, see those walls? Those walls are out. Let's have a coordination meeting. We can look at them. Yeah, you like my little video there, Trevor?
No, I was just, yeah. No, and I think that's something that's very impressive is the fact that, like, you know, I've heard of people just doing this with a tape measure and kind of being like, oh, I guess that's it, you know, kind of like, and kind of, I think it's a great example of how you guys are leveraging the technology to really kind of get the most out of not only laser scanning, but the tools available. You know, I think it's very impressive, you know, and this is not something that takes hours to do. This is the actual analysis of scanning. This is fast currency of information. And I think that's just something that's so powerful.
Yep. So with our streamline verification, we are able to get true as-builts. And what I mean by true as-builts is before, you know, laser scanning, Verity, Revit, all that fun stuff. You know, I'm a little older, so I remember having to do hand as-builts and going out there with the tape measure. The amount of data that you collect that way is not a true representation of what is in the field. This is giving me points every quarter, eighth of an inch, whatever, across the entire surface of every element that was built. And then not only does it get more information, I can get the information a lot faster. So if I were to try to hand as-built this entire floor that we're showing right here, that would probably take a crew at least a day to 2 days just to collect. That's not analyzing, that's just writing down data. Our whole process for this whole floor, from setting control to actually having a Revit model ready for coordination with a project team, I mean, you're talking maybe 5-6 hours. I can go out there first thing in the morning, set control, do my scans, have a coordination meeting after lunch, and tell them everything that is right or wrong or not there on their entire floor.
Hey, Mike, just for anyone that may not be familiar, I just want to emphasize the importance of control, but can you kind of simplify and give a brief overview of what control actually is for anyone that may not know?
Sorry, yes. Control are known coordinates on your site. So we will go out there and establish points on the deck, on the walls, whatever we deem appropriate, and they're known northing, easting, and elevations. And we tie those to the Revit model. So we put our Revit model on a shared coordinate system with those same coordinates, the same northings, eastings, and elevations. So that way, all the points of my point cloud have a known northing, easting elevation that aligns with my Revit model. So once we link them, there's no trying to align. Because I remember the old days of trying to align a point cloud to a singular wall and doing the rotate and nudge and spending 2.5, 3 hours. Hopefully it's right, okay? This, I know it is right. Everything is based off of coordinates and control in the field. That's we've really realized something here at Rogers O'Brien, and the fact that control and coordinate systems are what tie the digital world to the real world. And we're buying whole in on that. I mean, if we can't tie it down to a known coordinate, it's not accurate. Period, end of story, no ifs, ands, or buts.
On a job like this,
like
a
I said,
high rise, how many controls do you guys typically do on a scan?
So on this job right here, we take the control up through the building. We have 4 control points. Sorry about that. 4 control points per floor. We'll do 10 scans with 4 of those scans actually being on control, meaning we set up the GTL and run it like a total station, do a scan to where every point in there has a known elevation and northing and easting, and then we'll do a cloud-to-cloud registration for the other 6 scans. We're getting our RMS errors of 0.02 to 0.03. So I'm not a scan tech, so I don't know exactly what all that means. I'm sure Trevor probably knows a little bit more about that than I do. I just know that it's green, and when I tell people about it, they seem surprised.
I was going to say, to emphasize and really boil this down to simple terms, the higher precise your scan, the better the as-built model can be, and the better Verity and more accurate Verity is going to be. So multiple controls, multiple scans, multiple points, all of that's going to increase your precision and increase your accuracy throughout this process.
Mm-hmm. We don't really get a whole lot of scan drift when we're registering anything, just because of how we scatter our control throughout the building and register back to that same control. It really reduces the scan drift, so we can get a lot tighter scans and reduce that fuzziness that you can sometimes get in your point clouds. Summary of kind of how we're going to proceed from here. We're going to start implementing this on multiple high-rise projects throughout Texas. And we've also started getting with our BIM department. We have a lot of remodels where we're having to go in with a lot of existing conditions, a lot of existing MEP. And right now it is a lot of scanning and visually inspecting MEP, structure, architecture of, okay, line by line, just following this pipe down a wall. Does that point cloud match? Yeah, okay. Yeah, takes forever when you're talking about a huge, 20-story remodel. Yeah, now we can say, hey, let's run Verity and go and select all those elements inside the model, select the point cloud, and within a couple of minutes, we know where we need to go put our focus, because nothing is more detrimental to a schedule or to resource management than not putting your people focusing on the things that they need to be. Looking through 200 linear feet of ductwork that is all installed correctly or installed per model is not a very good use of resource management. Now, having a tool that can tell me, hey, 200 feet of this ductwork is great, but there's like 20 feet over here that's a little off. Go look at that 20 feet, not the 200 feet. You just cut our time way down. All right, I'll get off my soapbox.
No, it's a great point. And actually something I wanted to hit on just on the people is like, I think something unique is like the people doing the Verity analysis. This is not like, correct me if I'm wrong, Michael, but this is not like your VDC department doing this. This is like you were thinking, talking about. It's a super simple tool. It almost kind of brings the power of Revit to everyone, correct?
Yeah, I mean, like I said, I'm the one running all the Verity analysis, and I don't know Revit really a whole lot. All my stuff's learned from YouTube and Google. So if someone like me can run Verity, I mean, that's a fairly simple process. The UI, the user interface is phenomenal. It's very intuitive, and it makes it easy for people who aren't as Revit proficient to be able to run the analysis. Yeah, I mean, I don't do a whole lot of the reporting tools. I like the visualizations. I'm a picture guy. So being able to sit there side by side, click an element in Revit and have it pop up on my Verity screen of, okay, we're looking at this element now, or vice versa, and say, okay, yes, this one's out of tolerance. How much is it out of tolerance? Pull up the heat map. Okay, it's saying it's out of tolerance because it's out of plumb. Okay, that's a completely different story than something being completely off. Something's 1.5 inches out of plumb versus 1.5 inches located in the wrong spot. Those are two different scenarios that we need to know. And we don't have time or the resources or the manpower or anything like that to actually go and visually inspect every single column on every single floor for multiple projects. That's just not possible. It's not cost efficient. I mean, it's just bad use of manpower.
No,
But this, it takes that person and just does it for you.
No, I think that's, again, I think it's leveraging all the tools that you have at your disposal, really bringing the most out of it. And I think up on my screen right now, this is basically the workflow you guys use, which is establishing survey control. Again, super, and that's like the most critical thing I would say in this whole workflow, is that survey control is what really ties your digital world to your physical world. And if that's off, then all your downstream processes are also going to be off. That sets kind of like your base, I would say, And
bad
then,
information in, bad information out.
Yeah. And then another key thing I think that's also is that little the GTL 1200. That's actually a hybrid instrument. That's not a full, I don't think that's something we kind of really touched on, but I think it's a very special thing that you guys are using a hybrid instrument, really blending not just laser scanning, but actual survey workflows and kind of working almost seamlessly back and forth between them in Collage Site versus having to have a total station separate from a scanner, correct?
Yes, sir. It makes it really handy having just one piece of equipment we have to take out into the field. We can take our GTL, do layout, set control, and do our scanning all realistically with one setup. I mean, because we can go back and forth and we'll go set up our controls, do a scan, go set up another control, do a scan. It really makes the process a lot easier. And honestly, from a financial standpoint, if I can get a scanner and a total station for 15, 20 grand more than just a regular total station, I'm going to do that all day long.
No, it makes
just
sense.
from a business perspective.
No, and that's something for everyone kind of working here, or everyone kind of listening in the audience. It's also a great complement to any SLAM systems that you can use to help tie things into control. Or if you're using a traditional dedicated tripod-based system, you can again use it more as a complement. So I don't think right now it's a replacement. I would definitely say it's a unique tool, and I think it really shines in that verification, again, like Michael's workflow demonstrates. So
also with the GTL, we've actually started doing something with, because we own several different scanners now. We use the GTL for what we call anchor scans, and we'll have our field engineering teams go set control, the known coordinates on a project that we're going to scan. And we'll take the GTL and do that process, because we'll also provide scans of those areas on control to help register whatever other scanner, whether it's a Faro, a Navis, a Trimble even. And we'll use that to help tie everything back to our control system.
Yeah, and that point cloud itself, that's your anchor, not just like a couple. I think everyone, again, the amount of times like your survey point gets knocked over by a bulldozer or something. Instead, we actually have a full cloud, and that's, again, the redundancy. It's not just one point, it's millions of points. And I think that's a fantastic kind of pioneering use of a hybrid instrument. So no, I think it's actually incredible what you guys have done with that. And then the other is the linking part of the workflow, tying that digital world to Revit, and then the analysis portion too, and kind of producing. And again, the fact that I think the hardest thing when I've done Verity projects is by the time we kind of do everything, it's like, well, they've already moved like 2 floors up, so can't do anything. But again, you're saying like what, within basically before lunch, correct? Like you can have something for your project, and they're like, oh wow, okay, well, then I go fix it.
Yep.
Yeah, and I think that would be, I think that's compared to the traditional tape measure, the streamline, all those approaches, it's almost like night and day, It's like, and I really do think this whole workflow right here, I think you guys have really pioneered the verification workflow. And I think in your results that shows, I guess, kind of curious out of all of it, what do you think has like been the most kind of critical step as you've been developing it?
Ooh, that's a tough one right there. Because each thing does its own, each step of this process has helped us out in its own little way. But if I'm going to be honest with you, it probably is leaning more towards the Verity and tools for Revit side of things. While the GTL has helped us with field collection, we could do that with another scanner and tie it back to control. It's just a little bit more time having to run it through their registration software. The analysis part of taking a point cloud and comparing it against a Revit model, I mean, you're talking days of people just sitting there doing cut sections, going through, looking at the model. I mean, that's days that you cut off someone's schedule.
And this
But being able
workflow
to-
existed before, but with, you know, you'd have to take the Revit model and you have to export it out to Navisworks, and now you're in a whole new software. You're kind of minimizing your data silos, minimizing your jumping around between softwares in real time. With a push of a button, you can have Verity and Revit up in real time, and then you can just do that comparison as you're actually building the model, which saves a ton of time. I just do want to be mindful of time. So if we want to take a second and do our second poll here, we can go ahead and run through just now that you know a little bit more about Verity 2.0, just kind of taking a look through what is your most use case for using Verity. Is it construction verification, as-built modeling, progress tracking throughout your actual model design, going out and scanning as construction is actually being done, or pre-designed existing conditions? Let us know in the poll on your screen now. And then as we're running through as well, we'll circle back here in just a moment in some Q&A. So if you haven't already posted a question, go ahead and toss it in chat here, and we'll take a few minutes to answer some questions.
I'm actually genuinely curious to hear the results on these. I think one of the strangest ones I ever used Verity for was comparing as a dam, if you can believe it.
Damn, I can't believe that.
Yeah, it was actually, they were trying to figure out how much rock they had to blast away. It was like an earth dam.
Oh, wow. Okay.
So they had they modeled up the geometry, and then they'd scan it and then compare it with Verity, and wherever they had high spots or, you know, kind of red coming out, they'd take some, I guess they take some dynamite and just blew it off. But it was kind of one of the more, like I said, definitely unique cases using Verity for it.
Great use case, though.
All right, I think the poll, maybe like a little bit longer, should be wrapping up about here.
Yep, looks like the results are on everyone's screen here. It looks like as-built modeling is the most common, followed by construction verification.
Huh. Let me go ahead. I guess we got some questions, and it looks like I think Justin, our lovely PM, has been quite busy answering questions in the chat. So another quick little.
Yeah, a couple here that kind of stand out that Michael, you might be able to help us with. How do you get control to higher levels, or what is your process like for that scan data?
Oh yeah, so getting control up through multiple story buildings. There's a lot of people who have come up with various methods. We prefer to sleeve up through the concrete floor. So when we pour our slab on deck, we'll put 2 to 3 inch or 3 or 4 2 or 3 inch sleeves in the concrete pour. And that way we can take a laser and laser up through the slab going from floor to floor. This helps minimize sway when you're actually talking about a large story building.
And then let's see. So I say Justin's almost beating me trying to get the questions before I can talk about them. Again, Verity is its own app, or I should say there's two products that ClearEdge makes. There's Edgewise and Verity, two separate things. Edgewise is the scan to BIM, that's our pipe modeling one. And then Verity is the construction verification tool, which is its own beast. And that one is broken down into Verity for Navisworks, which again is not going anywhere, that's still there. And then there's also now the new Verity for Revit. Another quick little one, as we just kind of go into questions, we actually have a LinkedIn Live coming up. You know, please join us for that one. That's at the 26th at 1 p.m. That's going to be doing a lot more of a deep dive into kind of the Verity reporting side, using Revit to really get the most out of the verification reports. So again, join us for that one. That's going to be another fantastic one we have coming up. Hopefully that will be very valuable kind of as a tag team session. Now that everyone's seen Verity, now we can focus on kind of a little bit more of the downstream side of it. So, right. And then
a couple questions I want to answer here. So one of them, sorry, Trevor, I'm getting feedback from somebody, I'm not sure. But one of them was asking about, with Verity for Revit, do you need to be using a specific Revit template or have something specific inside of your model? So with Verity for Revit, you can use any template to start your project, because what Verity is doing is it's taking all of its data. When you run the analysis and bring it back into Revit, it's automatically creating all of those parameters and that parametric data. It's adding that in based on the analysis of the point cloud, but it's adding those parameters to the entire category of the element based on what it's analyzing. So anything with walls, it'll automatically add those to parameters to all the wall categories as instant parameters, and then it'll input that data based on where it is referenced in from the point cloud. Same thing with structural steel in the example here today. So you can use any template you need. Verity will take care of all the parametric data on the back end. And then I saw a question about point cloud data and creating models. Just going back a couple seconds ago to Trevor's point, ClearEdge 3D has an amazing software called Edgewise. That is actually, if you're working from nothing and you're trying to create a Revit model, it can actually analyze the point cloud, very similar to what we saw today with what Verity was doing, and actually comparing and understanding where the objects are. Edgewise software, though, is a dedicated BIM modeling software, so it's actually outputting Revit or CAD files of your 3D model and basically running through and analyzing that data. So ClearEdge has a whole suite of design software, a lot of cool stuff, and a lot of use cases for that.
Yep. Maybe like a couple more questions, and then I know we're getting a little bit over time here. So one of the big ones is, this will kind of be a twofer, I'll take it, but working with SLAM as well as working with the Naviz VLX. So at the moment, working with SLAM and construction verification, currently it is in beta. So if you're interested in trying that out, the results I've seen actually working with the VLX have so far been pretty good. I will say the limitations a little bit on like the object size. Again, SLAM data just tends to be a little bit fuzzier. So working with kind of smaller pipes and smaller objects, the results are can get a little interesting for the fitment. That being said, for working with larger objects like structural steel, stuff like that, or pipes over, I think it's about maybe like 4 or 5 inches in diameter, that's where it starts, that does work. It's more for the smaller stuff, that's where not so good. But again, that functionality right now, currently in beta. So if you're interested in trying it out, do let us know. So far, it has been initial, very promising results.
All right, I'm not seeing too many other questions here in chat. If we didn't get to your questions, we will try to shoot out a response. If you have anything, you can always email us at our, I'm not sure if we have a slide for that, but we do have our ClearEdge marketing email that you can always send questions out to, and we'll make sure to get you a response. Anything else you guys need, feel free to shoot it here in chat just in the last minute. And if not, Michael, we want to thank you for coming on. Michael's not part of ClearEdge or Topcon Solutions here, but he is from Roger O'Brien Construction, and he's been a great supporter here of Verity and all the tools we have here at ClearEdge.
Oh, thank you, Michael. Again, your feedback and kind of what you've been doing is absolutely invaluable. So,
not a problem. I'm glad to help. You guys help us, so I'm here to help you.
Oh, perfect. Thank you, Michael. And to everyone joining us today, again, thank you so much for taking part of this. This is a big milestone over at ClearEdge, something we've really worked hard. So again, any questions or anything, feel free to reach out to us. We're always more than happy to be a resource. If you're interested in trying Verity for Revit out, do let us know. We can also arrange that. And hey, with that, again, thank you, Jordan, also for providing the Revit support. Yeah, no, it's been a fantastic webinar, and yeah, so.
All right, thank you guys. Have a great rest of your week and have a good weekend.
All right, sounds good. All right, take care, guys.
Cool and take care, everyone.
All right, cheers, everyone. Bye.